Today I discuss a question from CSIR Net Mathematics, question number 66. The question from CSIR Net Mathematical Science to 2018 December. The question from part C, the question number 66. The question given that A be a real matrix of characteristic polynomial x minus 1 whole cube. Pick the correct statement from below. Option 1, A is necessarily diagonalizable. Option 2, if the minimal polynomial of A is x minus 1 whole cube, then A is diagonalizable. Option 3, characteristic polynomial of A square is x minus 1 whole cube. Option 4, if A has exactly 2 Jordan blocks, then A minus, this is actually I, A minus I is diagonalizable. So now we try to solve this. Now the solution. Here characteristic polynomial of A is given that x minus 1 whole cube. Now here the option 1, A is necessarily diagonalizable. We know a result from minimal polynomial that a matrix is diagonalizable if and only if its minimal polynomial can be written as product of linear factor. Right? If the minimal polynomial can be written as the product of linear factor, then we can say that the matrix is diagonalizable. So here also the minimal polynomial obviously divide the characteristic polynomial. This is a result that a minimal polynomial always divide the characteristic polynomial. So the possible minimal polynomial is x minus 1, x minus 1 squared, also x minus 1 whole cube. Then if this minimal polynomial is x minus 1, then we can only say that A is diagonalizable. But if the minimal polynomial is x minus 1 whole square, or the minimal polynomial is x minus 1 the whole cube, that is the characteristic polynomial, then we cannot say that A is diagonalizable. Right? So here option 1 is here, A is necessarily diagonalizable, but not, A is not necessarily diagonalizable, because if this and this be minimal polynomial, then A is not diagonalizable. So option 1 is incorrect. This is incorrect. Now the option 2, if the minimal polynomial of A is x minus 1 whole cube, then A is diagonalizable. No, only when the minimal polynomial is x minus 1, then A is diagonalizable. So option 2 is also incorrect. Now the characteristic polynomial of A square is x minus 1 the whole cube. if lambda be an eigenvalue of a matrix A, then lambda square is also eigenvalue of A square. So here the characteristic polynomial x minus 1 whole cube, right? Then lambda square is lambda square, this is also 1. So also the characteristic polynomial is x minus 1 the whole cube of the matrix A square. So option 3 is correct. And the next option, if A has exactly 2 Jordan blocks, then A minus I whole square is diagonalizable. Exactly 2 Jordan block. Since the eigenvalue are 1 1 1 from the characteristic equation is 0, then we get the eigenvalue is 1 1 1. So we can always find a matrix where principal diagonal element is 1, right? Then here the Jordan canonical form or Jordan canonical block are given that exactly 2 Jordan block, right? So suppose this is a Jordan block and this is a Jordan block. Also we can written this. This is also possibility. 2 Jordan blocks. So this is cannot happen. But 2 possibility, this and this, right? So first suppose j equal to this. Right. Then suppose this is A, right? 1 1 1 is the eigenvalue of the matrix A. So we consider the Jordan canonical Jordan block of A is this. Then A minus I. What is A minus I? 0 1 0 0 0 0 and 0 0 0, and A minus I whole square is obviously 0. So option 2 is here. A minus I whole square is diagonalizable. This is null matrix. Null matrix is always diagonalizable. So option 4 is correct.